Hi everyone, my name is Yiheng, and today I'll be presenting on my paper Explanatory Pluralism in Explainable AI, where I draw upon what has been said of explanations in the philosophy of science to help organize the different types of explanation and XAI methods that produce them, so we can be clearer when we request for and provide explanations. So many people request explanations for AI models, and the endeavor to supply such explanations has broadly fallen under the purview of explainable AI. Take the example of fraud detection within the ride-hailing ecosystem. Such a system involves many AI techniques, for example, a graph neural network to detect cases of driver-rider collusion, a type of fraud where the rider pays an accomplice driver with a stolen credit card, or LSTMs to detect sequences of fraudulent app activity that perhaps reveal no physical trip was actually taken. To the driver, one may question the outcome of such a system. Why was a particular trip flagged as fraudulent? But to the developer, one may be more interested in the accuracy of the model by measuring, for instance, the false positive rate. Furthermore, to lawyers, they may be interested in the compliance with regulations and laws, such as the GDPR. These explanations all help play an important role in ensuring the responsible usage of society, so we can determine whether or not such a system is admissible or not. To these aforementioned questions, we can provide many answers. But the question remains how we should evaluate the quality of such answers. Therefore, as a first step, it would be necessary to acknowledge the plurality of explanations and distinguish between the different types of explanation, so we can develop appropriate evaluative criteria and techniques to address these different requests. It would be unfair to compare apples with oranges, and before we make such a comparison, we should sort the apples from the oranges. It is not clear to me that a descriptive organization, such as whether or not this answer generator was before or after the model processed the input, would help us in assessing how suitable a given explanation is. At best, they may be useful heuristics, but it would be better if we could develop an evaluative taxonomy that explicitly demarcates between different sets of evaluative criteria. So in this paper, there are three main key objectives. Firstly, I appeal to the philosophy of science to clarify this notion of selectivity, how we should select the right sort of explanation for a given request. And secondly, I would then use this notion of selectivity to propose an evaluative taxonomy rather than a descriptive one. And lastly, with this proposed taxonomy, it also introduces a clear and distinct terminology to express the different types of explanations requested for and organize present XAI methods. To ground how we should be selective on the explanations which are good, how we should evaluate them, I start from a point where XAI and the philosophy of science agree upon. This is the importance of unveiling causes in explanations. We can further specify what we mean by a cause by appealing to the notion of a manipulationist account of causation, where causes are understood as manipulable relationships. So X causes Y if manipulating X changes the value of Y or its probability distribution. But the fact that explanations merely identify causes is insufficient selective criteria. We need a further notion of causal relevance. So in the mechanistic account of explanations, Craver explicates this notion as in picking out the causally relevant changes, one is searching for a cause contrast that is appropriate for a given effect contrast. And this is on the whole an empirical endeavor. We will require experiments to determine whether or not a change is appropriate for a given effect contrast that we're interested in. In summary, on the mechanistic account, the causal organization that is reviewed by different explanations identify different relevant relationships which can be exploited for the purpose of manipulation and control. So to effectively address the request for explanations, we should first provide causes that is relevant to bringing about changes in the requested contrast class. So in this case, we need to clarify this contrast class in our request by taking a close look at the bigger picture. Where do our AI models fit in? So just looking at the model itself, we can already distinguish distinct levels of analysis, and it's inspired by David Marr's framework. At the implementational level, specific hyperparameters for a model, or the hardware that's used to train it, then realizes the network architecture or the algorithmic level. At this level, are we using a graph neural network, a recurrent neural network? These architectures thus chosen are used to fulfill some computational task or goal. For example, fraud detection, but we can be further specific. Are we framing this task as a clustering or classification problem? But more broadly, we also have to acknowledge that AI models XAI is interested in are those which have significant impact on humans and occupy positions usually associated with certain expectations and constraints, explicitly or implicitly. Also, it is rarely the case that model output will be directly used in decisions or raw data fed into the model. So we also have to acknowledge the embedded nature of our AI models. This provides two ways we could distinguish what we are targeting. Firstly, are we targeting the mechanistic level, or are we targeting the social level of analysis? Secondly, are we looking at a particular output of the model or the pattern of AI model output in general, in context of its embedded computation? So in my proposed taxonomy, we can clarify requests for explanations along these two axes: a social mechanistic level analysis and a particular general level of specificity. Within the mechanistic level of analysis, for a particular AI output, are we talking about the general AI model in question? Within the social level analysis, are we talking about a particular natural person or persons interacting with such models? Do they understand these model output? Or are we analyzing the general kind of social context under which such models may be deployed? The organizing consideration here is to recognize that different types of explanation identify different points of intervention within some AI system. Taking into consideration both the embedded nature of an AI's computation as well as the role it functions to fulfill, we should then evaluate putative explanations based on how successful their respective interventions are for their respective purposes. There are two things to note in this taxonomy. One important feature is that this pluralistic stance means we don't need to acknowledge that a single sort of explanation is by default more suitable than another, right? That we cannot reduce any one category identified by this taxonomy to a combination of the others. So, for example, raw explanations do not cover the whole story, but nor will a combination of explanations from the other categories substitute for one, right? Without identifying the role, we cannot tell whether even a correctly functioning AI model may nonetheless be improperly employed. However, the second thing to note is I do acknowledge that the dependency relations may indeed occur between these categories. For example, we may require diagnostic methods to verify the correct implementation of rule-based AI models, or whether theoretical robustness guarantees break down in specific adversarial cases. Right? Furthermore, to establish that an AI model acts within the constraints of a given social role, we may well require that the output be explicable and that they satisfy certain robustness guarantees. However, it's not the case, once again, that an particular sort of explanation from one category can satisfactorily substitute in place of another. So now with this taxonomy, it allows us to separate questions for which we should have different methods to address them. This is useful for us to make progress independently within each of these categories and choose the most suitable technique from each to formulate a more holistic XAI approach. For example, most of the basic techniques developed in XAI fall under the category of diagnostic explanations. These include generating saliency maps, rendering text-based feature importance using the LIME tool, or more generally, feature relevance by computing shapely values. At a high level, the increasing attention to interpretable models rather than explainable models makes the move to place attention on this expectation explanation category. These include, once again, using more interpretable architecture, which enables us to easily formulate expectations of their behavior, building more robust models, or ensuring that the data we feed our models are free from bias. On the social side, to render the model output more understandable, perhaps we should look into human-computer interface research to build better interfaces, represent feature relevance in terms of contrasts, and develop metrics to measure the extent to which receivers can understand the manipulable relationships thus revealed by explanations. Lastly, in the role explanation category, we may for now include humans in the process of decision-making and training, pre-plan risk mitigation protocols, and develop more regulations to clarify the roles we envision AI can permissibly and beneficially act within. So once again, with this taxonomy in place, we can go back and organize the answers in our previous fraud detection example. By adopting this pluralistic stance, in addition to having clear evaluative criteria for each of these categories, we further observe that perhaps the stakeholders' requests involve multiple categories of explanation. For instance, the driver may be not only interested in the particularly relevant feature or features which resulted in the decision, but also how these features impact himself or herself. The developer may request for further diagnostic explanations to verify the correct implementation of a certain architectural choice. And the lawyer may request for robustness guarantees that the model has, in addition to how it fits within the decision-making process. Right? So, in conclusion, we can and should adopt a pluralistic view on explanations based on the different points of intervention in the AI system. So then we can evaluate the different types of explanation produced on the success of their respective interventions. This proposed taxonomy is but one way we can come to organize the methods in XAI. And it is neither complete nor the only one. We may have subcategories or other ways of drawing the line between different explanations. But it's my hope that we can come to adopt a more pluralistic stance on the explanations provided by XAI and recognize that each have their own limitations. So going forward on the short term, we should reframe the particular mechanistic methods which are currently prevalent in XAI as producing diagnostic explanations. This is to prevent it from overreaching in what requests it can fulfill. Next, on the long term, perhaps XAI can not only contribute by identifying points of intervention, but also eventually allowing us to reflexively surface those interventions back to the AI itself. So here, philosopher Rosenberg coins the term ratiocinnative AI as opposed to merely rational AI by distinguishing between being aware of rules versus the mere following of such rules. One example, however, still far away from this goal is Move Zero, which learns the different constraints on its action space through reinforcement learning. And this is in contrast to having the rules being explicitly specified by the designers of the system. So by exposing more reflexive interventions to our AI, we introduce additional flexibility to perhaps align it better with our human goals. So with that, I've come to the end of my presentation, and I thank you for your kind attention.